Everyone, April 24th. Alright, yesterday's problem. It took so long and eventually I did it, but look at this. We start from, actually earlier than that, we start before 9 o'clock, I think around maybe 8:30, and I finally finished at 2. I mean, one of the hours I did something else, but still, it's a long time. And then the solution is like nothing special. Right? It's like nothing special. Like my solution shall work. And then I realized the reason it does not work, that it just kept timing out, it probably is because of this line. You see this line? The trouble of this line is every time we are copying the string and then we turn it into an int, I think this is taking a long time, which could have been fast. Like here, you see, it's just times 10 plus something. So I think this solution definitely works. This is the right solution. Like, because at TLE, and I tried my best to, to play with the pre-sum. Oh my God, the amount of effort I've put in to do the pre-sum is ridiculous, and it still doesn't work. It's just because of this thing. This thing is constantly throwing me off, and I did not realize it. I think that's the reason. So I think today I'll do this one more time using this method, but definitely not doing this. Yeah, this is not happening. I'll do something else. Something similar to this, right? Similar to this, but this is like top down, and I want to try the bottom up. I mean, this is not a difficult question. Like people say in the comments, it's not a difficult question. It's a very straightforward DP, which we already realized. We did realize. That's the thing. We realize it is a DP, right? It's a 1D DP. We realize it. But for crying out loud, I picked the wrong way to check, and then just time out and didn't know how to deal with this. Unbelievable. All right, let's do today's first, which I hope will get done really fast. While given an array of integer stones, and a stone's eye is the weight of the ith stone, we're playing a game. On each turn, we choose the heaviest 2 stones and then smash them together. Suppose the heaviest 2 stones have weights x and y, with x smaller equal to y. The result of smash is, if they're equal, both stones are destroyed. If not equal, the stone of weight x is destroyed and the stone of weight y has a new weight. At the end of the game, there is at most 1 stone left. Return the weight of the last remaining stone. So this is apparently a priority queue. Maybe we're doing priority queue this week. Not this week, it's like these sequences. Maybe it's priority queue. But anyway, this it's pretty simple. No, I like to do import heap queue. I haven't used them for a while. I already forgot. And we need to heapify it. So heap equal to for s-ing stones, we have to do negative heap q dot heapify heap, right? And then we say while len heap is larger than 1, right? We can say y equals heap q dot heap pop heap x equals to heap q dot heap pop heap, right? And then we say if x is not equal to y, heap q dot heap push heap negative abs. I don't need negative abs. I can just say y minus x. Right? Because y is bigger, which is more negative. So this won't be a negative value. So I push this in. And we do this, and then we return heap 0. That shall do. Sorry. Thank God we tested. Alright. I'm not confident. Yeah, this should be right. April the 7th. What? What condition I did not consider? 2 and 2. Huh? 2 and 2. Holy crap, what is 2 and 2 then? Oh, no stone. Sorry. Didn't see that. That was bad. That was bad. I didn't notice. Did not notice. First is a negative and I forgot a 0. It's alright. One 0 4 6. Pay attention to the situation where heap is empty at the end. N log n, right? We're gonna call it n log n. Okay, this one's done. Now we go back to yesterday's problem. And we're gonna do bottom up. Basically, the same solution as this, but that should be solution 4. Okay. Bottom up. Do not do int str to obtain a number for comparison with k. Do it iteratively. I think I'll still do this. There's no such a thing as 0. Right, and then this we're just gonna do times this. And this will be 1, right? And then for I equals 1 to the end, it doesn't really matter, does it? No, it does not. So what do? From 1 to the end, for each one, we will have its value, right? We'll have its value. And we say if it's a 0, then we have to go, oh, we do need the maximum k. I think this will help us. This will help us, right? Because I know how many to go backwards. So we're at I, right? Now we can say the current value is whatever it is. And then we can say how many times we need to go left. Right? Every time we'll pick it up, right? I'm going to say accumulation is equal to, but we also need the current value, right? Because the current value is 0. We can increment it, but we need to, hold on, if the current value is 0, right, then we shall just add 0. Basically we just skip it, right? We just skip it. So shall I say ACC is equal to 0? Okay, I'm going to say for J in range from I all the way to something. Okay, what is this something? Well, the minimum can go to the -1. And then we say we can go I minus k So if k is 3 digits, right? Then we say 1, 2, 3. That's right. So you get the maximum of this. Okay, so I have j. Oh, but how many times? Okay, I need a tens. Start with 1, right? So we can say ACC. We can say current is equal to int. We still need int, but just SJ, right? So if current is not equal to 0, if current, then accumulation shall equal to what? Accumulation shall equal to ACC times tens plus current. No, that's not right. It's current times tens plus ACC. Right, the current value times the tens, which is 1 initially, plus ACC. And then we say if ACC is smaller or equal to k, then DPI, we can say equals DPI plus DP, because we say j, right? We're looking at j at the moment. So j to the n is good. So it should be dpj minus 1. So in this case, I do think we still have to do 1 to the n. 1 plus. Can we start from this? I guess we can. It's fine. Then dp, oh, then it should be I plus 1, right? dpi plus 1, dpi plus 1 plus dpj. And then this will be mod. Else, then we just break. Or we just go through everything. Then we'll break as well. Right? And then when this done, tens, well, times equal to 10. And then we'll return dp minus 1. Okay, let's see if this one's right. Mod is not defined. Okay, mod 10 plus 7. Yep, look at this. Like I said, right? Just do it iteratively, then it will work. It will work. So it is a very simple problem. It's just that I did not pay attention to what causes the issue, right? I just did not pay attention to what causes the issue. And I thought the issue is because I did not use prefix sum. And I was spending so much time trying to figure out prefix sum, but actually it's not. See, just go through this. It's so simple. So simple. Terrible. You want to give this one more shot? I don't know. It's kind of late today. I don't want to give it another shot. And actually, I want to think about this one more time. Whatever I had, I think it's not right. Yeah, we still haven't finished this one yet. But anyway, let's just call it a day today. Yeah. Tomorrow is going to be a very busy one because I need to finish editing the paper. Not even sure if it's going to happen, but we'll have to do it. Yeah. Okay. That'll be it. I'll see you guys tomorrow. Adios.